Hello everyone, welcome back to my channel Placement Guidance. Tomorrow many of you are having your Capgemini exam. So in this video we will cover the recently asked DSA and pseudocode questions with answers with the shorter tricks. And if you haven't subscribed my channel, please subscribe the channel and share this video with your friends who are having their Capgemini exam tomorrow. So let's get started. So the first question, this is from DSA. What they have said that if we draw a binary search tree by inserting the given numbers from left to right, they have given us these numbers and we have to insert that into BST from left to right. That we have to start it from here, and then what would be the height of the BST? We have to find the height of the BST after forming this. So what do you mean by binary search tree? So BST says that the left child of the root node should always be smaller and the right child of the root node should always be greater. That means suppose this is a number 50, so this is the root node. So this 25 is the left child of this 50. So what does BST says that the left child should always be smaller than its root node. So 25 is smaller than the 50 and the right child should always be greater than its root node. So this is a binary search tree. Okay, so now we will continue with the question. So this is the first number that they have given. So this will be the root of a tree. So 67 will be the root. After that, the number given is 66. 66 is lesser than 67. So it will come in the left. 66. Now the next number is 53. So now see, we will see from the root node that 53 is smaller than 67. Yes, so we will come to the left. Now 66, now 53 is also smaller than 66. So we will place this 53 to the left of this 66, sorry. Now the next number is 62. So again we will see from the starting the 62 is less than 67. So we will come to the left child. Now 62 is also smaller than 66. So we will again go to the left. Now 62 is greater than 53. So 62 will be at the right of 53. Now the next number is 55. So again we will see from the starting that 55 is less than 67. So we will come to the left. 55 is smaller than 66. We will again come to the left. 55 is greater than 53. So we will come to the right. Now 55 is smaller than 62. So we will place this 55 to the left of the 62. Now the next number is 68. So see, 68 is greater than 67. So where we will place this 68? To the right of 67. So this is how we will form the BST. So now after that they said that you have to draw the binary search tree from these numbers starting from the left to right. Now what we have to find? We have to find the height of the BST. Height of the BST, we will see the longest path in this. So the longest path is this one only. So how we will see the height? Just count the edges. 1, 2, 3, 4. So the answer for this question is option number C, that is 4. Now we will see the second question. What will be the output of the following pseudocode? So here they have declared 3 variables and here they have initialized the 3 variables. That is the P with the 7, Q with 8 and R with 7. Now they have given one for loop for each R from 5 to 8. So that means it is a simple for loop. What it is saying that R will start from 5 and R will be less than equals to. Keep this thing, keep this point in your mind that it will be less than equals to, not only less than. So if it is given that for each R from 5 to 8, so it will be till 8, not less than 8. Okay, so this is the one point to be remember, and then it will increment by 1. So this is the for loop that they have given starting the R from 5 and R should be less than equals to 8. So now what they are doing, in the starting the value of r will be 5. Now we will come inside this for loop. What it is saying, if q is greater than r, so the value of q is 8. So is 8 greater than 5? Yes, true. So we will come inside this if. What it is doing, q is equals to 5 plus 1, that means q is equals to 6 plus p. So the value of p they have given is 7. So 6 plus 7, it will be 13. So the value of q will be 13. And now see, now here the if ends, and now they have given q is equals to 11 plus q. So the value of q will again be changed from 13 to 11 plus 13. So now the updated value of q will be 24. Okay, now it will increment r by 1. So now the value of r will be 6. Is 6 less than equals to 8? Yes. So we will again come into this for loop. Now we will again check this condition, that if q is greater than r. Yes. So now the value of q is 24. So now we will see that 24 is greater than 6. Yes, true. Now condition again satisfy. So what we will do, we will update the value of q to 5 plus 1 equals to 6. 6 plus p. So what is the value of p? 7. Because here we are not changing the value of p. So the value of p will remain 7. Now the value of q will be 13 now. Now what will happen? Q is equals to 11 plus q. So the value of q will be 11 plus 13. That will be equals to 24. Now the value of r will be incremented. So the value of r equals to 7. And is 7 less than equals to 8? Yes. So again it will come into this for loop. And now see, the value of q will remain 24, because what it is doing, it is doing the constant thing again and again in this for loop, because the value of p is not changing at all. So here the what will the value of q will remain same, that is the 13. And here also the value of q will be 24 only. 11 plus 13 equals to 24. So if you will run this loop 100 times, then also the value of q will be 24. At the end of this for loop, the value of q will remain 24. So no need of doing it again and again. If you see that the value is not changing, so what you can skip further process, and you can take the value of q as 24, because you can see that again it will check that 24 is greater than 6. Again it will update the value of q to 13, and again it will be 24. Same thing it will do. So at last what it is doing, it is printing p plus q. So what is the value of p? The value of p is 7, plus what is the value of q? The value of q is 24. So at the end what will be the value? 31. So the answer for this question is A. Option number A, that is 31. Now we will see the third question. What will be the output of the following pseudocode? Again they have declared three variables. The value of p is 2, q is 7, and r is 6. Now what it is doing, it is checking the condition that if is r, and this is a bitwise AND operator. So if it is a bitwise AND operator, first we have to convert these variables, like the value of these variables, into its binary equivalent. Then only we can calculate it. So the value of r is 6, and it is showing bitwise, and then p. So the value of p is 2. So this is a first, like, change all the variables to its value. So 10 minus r. So the value of r is 6. First take the part before or, because if a condition is true, so we don't check the second condition in the case of or. If here it is and, then we need to check the second condition. But if it is or, then if the first condition is true in the case of or, then we will only check the first condition. We will not go to the second condition. So this is the first trick you should remember. If it is or and if it is true in the first condition only, no need to check the second condition. So first we will see it here only. So the binary equivalent of 6. So if someone do not know how to calculate the binary equivalent, what you can write like 1, 2, 4, 8. Remember this. If you want to find the binary equivalent, you can just write 1, 2, 4, 8. The power of 2, it will go on like 16, 32, so on. So if it is 6, so how the 6 can be formed? 4 plus 2, 6. So this is the binary equivalent of 6. Now the second number is 2. So we will keep 1 at the place of 2 and other we will fill with 0. So now we have changed this values with the binary equivalent. So the operation it is doing is bitwise AND. So in bitwise AND, what it says that if both the values are 1, then only it will be 1. Otherwise, if there is any 0, it will be 0. So what will be the value for this is 2. The decimal equivalent of this binary is 2. Now what it is doing, this is 2 less than equals to 10 minus 6, it is 4. So is 2 less than 4? Yes, true. So it is or here. So we no need to check the second condition. We will go into this if. So what it is doing, r equals to r plus p plus p. So what is the value of r? 6 plus the value of p is 2 plus 2. So the value of r here, it will be 10. No need to check the else condition because the condition for if is true. Now we will print here like p plus q plus r. So the value for p is 2, the value of q is 7, the value of r is 10. So the answer for this is 19. So we will mark the option C, that is 19. Now we will see the next question. Again, it is a pseudocode. What will be the output of the following pseudocode? Again, they have declared 3 variables. Then they have initialized p with 9, q with 5, r with 8. And what they are doing, r is equals to p. Now, I have told you that this is a bitwise operator. So what we have to do, first we have to change these values to its binary equivalent, and then we will solve it. And this is the sign for the XOR. Now we will see this sign. So first we will change the variables with its value, like p we will write its value 9, and then q with the 5, and what it is doing, XOR p. So the value of p is 9. So now we will change this 9 to its binary equivalent. So the binary equivalent of this is 1 0 0 1, and the binary equivalent for 5 is 0 1 0 1. Now I've told you how to find the binary equivalent in the above question. So now you can, I hope you can find the binary equivalent. So now the operation is bitwise AND. So bitwise says that if the both values are 1, if both the values are true, then only it will be true. Otherwise it will be 0 if there is any 0. So it will be 0. So this 9 bitwise 5, the value for this will be now 1. So now what we have to do, 1 XOR 9. This is what we have to do. So now again for finding the XOR, first we have to change this to its binary equivalent. So the binary equivalent for 1 is 1 only, and for 9 it is 1 0 0 1. So here we will put 0 0 and 0. Now what does this XOR says? XOR says that if both the values are different, then only it will be 1, and if it is same like 1 1 0 0, then it will be 0. So the decimal equivalent of this binary is 8. So here, from here we find the value of r as 8. Now here you can see that what they are doing, they are finding the value of q 2 times. So if if this value of q is like, if they are putting here, then only you can find it, otherwise no need to like find the value of q here, it's of no use. But if you want to, like, you can, q is equals to r plus r, so the value of r is 8, so it will be 8 plus 8 16. But no use of finding this q, because they are updating the value of q again, and they are not using this value. I mean to say, like, they are not using this value further, so no need to find this. So again they are updating the value of q with 7 plus the value of p is 9. So 9 plus 7, it will be 16. So the value of q is 16. So now what they are doing, they are printing p plus q plus r. So the value of p is 9, the value of q is 5, the value of 8 is, sorry, the value of r is 8. So the total count of it is 33. So the option is B, that is 33. Now we'll see the next question. What it is saying, find out the array representation of the, this is a DSA question. Find out the array representation of the given max heap if the value 15 is deleted from it. They have given the array representation of the max heap, and they are saying that if they will delete 15 from this, so what will be the array representation. So first we will make the max heap from this. So we just have to like make the binary tree, like max heap from this 23 and then 20, like we will keep this left to right, like 15 here. After 15 it is 14, so we will keep this here, and then 11 here. We just have to keep this values like 23, 20, 15, 14, 11, and then 8. So now what they are saying if the value 15 is deleted from it, if this value 15 is deleted from this max heap, then what will be the array representation of this max heap. So if this 15 is deleted, so the last value, that is a 8, will be replaced with this. So this is a very simple question that they have given. So this 15 will be replaced by 8, and we will remove this 8 from here because it has been moved upper. So now see, now you just have to write the array representation just like this. Like first 23, then 28, and 14 and 11. So here where we are finding this option 23, then 28, 28, yes, 14 and 11. So we find this in option A. So the answer for this is A. Now sixth question, what they have given, solve the given postfix expression. So how to calculate the postfix expression. So the if there is value, so what we will do, we will take one stack, and if there is value, we will just push it into the stack. So we will push the 4 into the stack. Again it is a value that is 1, we will push it into the stack, and again it is a value that is 2, we will push it into the stack. Now there is operation, that is the multiplication. Okay, so what we will do, we will multiply the first two upper values, like the first two upper values is 1 and 2. So what we will do, we will multiply this 1 into 2, so the value is 2. So see, we will pop out this two values and we will multiply this. So 4 is already there in the stack, and now after multiplying, the value that we are getting is 2. So this is a stack right now, and after the, again there is operation, that is division operation. So again we will pop out these two values. How we pop out, like how we will do this divide, we will do it like this: 4 divided by 2. We will never do like the 2 divided by 4. You're getting this point, how we do, we will take the, like, if it this is simple multiplication, but if it is minus sign, then we will do it like 1 minus 2, not 2 minus 1. So we will first take the lower value and then the upper value. So how we will do the division operation? 4 divide by 2. So now it is, the answer for this is 2. So this is pop out from the stack. So the value remained is now only 2 that we have got after this division. Now there is value. So what we will do, we will push it into the stack. Now there is operation plus operation. So we will add this two values. So how we will add 2 plus 5. So the answer for this is 7. So we will mark the option C as our answer, that is 7. So hope you like the video. Thank you.